Hey, good evening friends. Welcome back to the sprint of grade 12th session number 2 for physics. I welcome you all. My name is Bhavdeep Sir. I'm a physics master teacher here. I love physics, I love kids, and I love teaching physics to kids. Many of you already know me. For others, welcome to my classes. So day number 2, this is the schedule here. Today it's 29th of January. We are covering electric potential and capacitance. We have already covered electric charges and fields yesterday. If you have not seen that, please make sure you do see that. Before I start, I would like to remind you, please subscribe to the YouTube channel here. Press the bell icon so that you can get updates about the upcoming courses. We keep coming up with exciting free courses here. Make sure you also share this YouTube channel with your friends, relatives, neighbors, classmates, so that they can also take advantages of the free education here. Now, strategy as yesterday and as always is going to be make sure that everything is simplified. Derivations, calculations, numericals that you always found difficult, that look lengthy and boring and so difficult, they're going to be simplified for you. So the strategy is simplification. In many of my questions, you'll see this icon. So why are we talking about the board exams? Because most of the engineering colleges, medical colleges, they go by the competitive exams. So why are we even talking about board exams here? For a few reasons. Number one, if you're looking for admission into IIT, NITs or any of the centrally funded technical institutes, you're supposed to get 75% marks in your board exam or in the top 20 percentile in your board. For medical, you need to be scoring 50% in physics, chemistry and biology. Now that's important, but then also we are not here just to score marks, just to get percentiles and all that. We are here to learn physics. How do you learn physics? The good part with board exam, as I was telling you yesterday, is that you have to learn the derivations, you go through the subjective type questions and theory questions, and that makes your concepts clear. So make sure you give enough importance to your board exams in addition to competitive exams. Now, आज क्या करना है? आज का एजेंडा क्या है? आज हम करेंगे capacitors and potential. It's all about potential today. Part 2 of electrostatics. And electrostatics total comes for 8 marks. आज का session, yesterday का session combined for 8 marks. Now, your strategy should be to learn this, to score marks here. You're supposed to do all the derivations in your NCERT book. I was telling you yesterday, NCERT is the most important book for your board exams. Back exercises, jitne bhi questions, including your additional questions in there, you're supposed to completely be comfortable with them. Unko ratta nahi marna hai. You should be understanding all those concepts, doing them yourself. No, I mean, it's too late in the game now if you've already done that, but please try. If you have not done those questions, too late in the game in the sense I was saying, if you have already seen the solutions, you should not have done that. But if you have not done these questions, it's a good time that you start doing these questions without referring to any solutions. If you're able to do this without solutions, guaranteed. Right. Past year question papers, 5 साल के पेपर करने हमने, at least 5 साल के, ज़्यादा करने हैं तो करो, at least 5 साल के. The way you have to do them is look at the question, think about what you're going to answer for them. If you have time, you write down the solutions and compare with what the marking scheme is. You're supposed to compare that. Now, this slide always comes up here, and this is about the right way to learn. So let me move out of your way. So gravitational versus the electrical potential. Is पानी के टैंक को देखो. What are we doing? We take a water motor, and we take water molecules and we move them up. As the water is filling the tank, what is happening? Water molecules are rising up. 9th के level की gravitational का formula देखें तो mgh. Water molecule was at the earth, water molecule moves up. It has mgh of potential energy. Why do I do that? I do that so that I can get a sudden burst of that energy, that potential energy, converting into kinetic energy and supplying the water to all the houses in there, because there's a lot of pressure built in now. Same thing with capacitor. Capacitor में क्या कर रहे हो? You're putting in those charges like water molecules. As you're putting each charge, that charge gets electrical potential energy, and then you can use that sudden burst of energy, convert this potential energy into kinetic energy. Kinetic energy in this case is going to be electrical current. So again, one last time, water molecules, charges. Water molecule potential energy, gravitational potential energy, is the charge's electrical potential energy. Water molecule flow, which is the kinetic energy, is the charge flow, which is the electric current. This is the right way to learn this, because now you can see what's happening, you can visualize that. So let's get started now with question number 1 for today. What do you mean by conservative nature of electric field? And again, we are going to compare that with gravitation, because with gravitation you can see that. Pen यहाँ रखा है, pen यहाँ ले गए. How much work is done? यहाँ रखा था यहाँ ले गए. You will say mgh. Now you don't really care कि मैं पेन ऐसे ले गया, or did I take the pen like this, or did I take the pen some crazy way and then stopped here. It doesn't really matter to you. What matters to you is where was the starting point and what is the final point. So initial position, final position, that's what matters to you, and that is what the work done against gravitational force is. And that is because the gravitational force is a conservative force. Same goes with electrical force. Now electric field, conservative nature, uska kya matlab hai? See, remember yesterday I said field. What is field? Gravitational field. नीचे अगर जा रहे हो, देखो. So let's see that one more time. So what is gravitational field? Gravitational field is chota g, 9.8 meters per second square, but you can visualize that as 9.8 newtons per kilogram. So if there is 1 kilogram here, it's experiencing a force of 9.8 newtons there, right? Now when you pull up a thing against that field, you're going to be doing some work, and that work is irrespective of whatever path you take. And that's exactly what is electric field. I'm going to move out of your way so that you can see that picture here. So electric field, gravitational field, whatever work you do is irrespective of the path taken. It only depends on where the body was or where the charge was. There's an electric field here, I take this charge from here to here. Doesn't matter did I take along a straight line or some other path, doesn't matter. And this is what you write. 1 mark question. पहले समझना है उसको, दिमाग में सोचना है कि what is being asked and what am I going to respond to that, and then you frame the answer in your own words. रट्टाफिकेशन से काम नहीं चलेगा. Question number 2 here. What happens to the capacitance of a parallel plate capacitor if the area of the plate is doubled? है ना? You can clearly see that icon over there. That icon says this is a very simple question. फर्स्ट ऑफ ऑल किसकी बात हो रही है? पैरेलल प्लेट कैपेसिटर आ गया, पैरेलल प्लेट कैपेसिटर दिमाग में आ गया. देयर आर 2 प्लेट्स, वन हैज पॉजिटिव चार्ज, वन हैज द नेगेटिव चार्ज. ये दिमाग में आ गया. उसके बाद उसका फॉर्मूला, व्हाट इज द एक्सप्रेशन फॉर कैपेसिटेंस? वी आर गोइंग टू डिराइव दिस इन वन ऑफ द क्वेश्चंस टुडे, बट यू माइट हैव ऑलरेडी मेमोराइज्ड दिस. कैपेसिटेंस इज इक्वल टू एप्सिलॉन मल्टीप्लाइड बाय एरिया डिवाइडेड बाय द डिस्टेंस बिटवीन द प्लेट्स. Up, they're not changing the medium between the plates, so epsilon is still the same. D is not changed, that is still the same. C is directly proportional to the area. एरिया को 5 टाइम्स कर दोगे तो कैपेसिटेंस 5 टाइम्स हो जाएगा. एरिया को 1/10 कर दोगे कैपेसिटेंस 1/10 हो जाएगा. यहां कहते हैं डबल कर दो, डबल कर दो तो डबल हो गया. That's all. You just visualize all this and then you frame your answers. You don't have to ratify anything. So I'll again move out of the way here. So this is just a sample solution, right? I'm just giving you sample kind of this. You can write the answers in your own words using your own grammar and own vocabulary. Main thing is you frame the answer in your mind before you answer them in the board exam. Next question here. देखो आराम से, मैं फिर से move out हो जाता हूँ. A charge Q move from A to B. अब इसको ऐसे विजुअलाइज करो, सिंप्लीफाइड. वो आइकन जो है ना वहां पर, वो दिखा रहा है कि दिस इज अ सिंपल क्वेश्चन. देखने में लगता है वर्क डन, एक्सेलरेशन, व्हाट इज ऑल दैट. सो देयर इज नो एक्सेलरेशन. एक्सेलरेशन जीरो मींस क्या? यहां पे जीरो वेलोसिटी पे था, इट हैज टू बी कमिंग विद जीरो वेलोसिटी है. ब्रिंग इट सो स्लोली टेक्स यू अ जिलियन इयर्स टू डू दैट. हाइपोथेटिकल सिचुएशन, राइट? It should take almost zero acceleration. धीरे लगे 10 साल 20 साल जितना भी लगे. So the whole point there is no change in kinetic energy. So the net work done has to be zero. अब वर्क पे जाओ, वर्क डन कितना होगा? काइनेटिक एनर्जी चेंज हुई तो वर्क डन विल बी इक्वल टू द पोटेंशियल हियर and potential here. Subtract them, right? You're bringing from here to here. It was supposed to be potential energy of the charge here minus the potential energy of the charge here. Now look at the symmetry here. This is bisector, perpendicular bisector. कोई भी पॉइंट ले लो बाइसेक्टर में, पोटेंशियल एनर्जी पता करो, k टाइम्स दिस क्यू डिवाइडेड बाय दिस डिस्टेंस, बट दैट इज नेगेटिव. Then because of this, k times this q divided by the same distance, that is positive. So any point on this has zero potential energy. So charge had zero potential energy here, charge has zero potential energy here. जब zero था, zero है, तो there is no change at all. So there is zero work done. But ऐसे frame कर लेना आंसर को दिमाग में, and then you can write it like this. I'll just show you how to write. And again I'm saying this is just a sample. You don't take a screenshot here, don't rectify. That defeats the purpose of learning physics. है ना, एग्जाम पॉइंट ऑफ व्यू से पढ़ना है, बट देन दैट डजंट मीन यू रेक्टिफाई एनीथिंग. यू जस्ट ट्राई टू अंडरस्टैंड द कॉन्सेप्ट्स and you can crack any of the exams, subjective exam, objective exam, any kind of exam. Okay, 3 capacitors, again that icon comes in there, है ना, क्योंकि बिकॉज मैनी स्टूडेंट्स थिंक ओके सीरीज पैरेलल ये सब याद नहीं है, फॉर्मूले याद नहीं है, डजंट रियली मैटर टू यू. देखो कैसे ये यहां पे ले आया, लेट मी शो दैट. 3 capacitors are in series here. Now think about it, how do capacitors get charged? There is a battery here that is going to pump in negative charge to this. तो यहां लिख देता हूं मैं नेगेटिव क्यू यहां पे आ गया. अगर यहां नेगेटिव क्यू आ गया, इट्स गोइंग टू रिपेल इक्वल अमाउंट ऑफ इलेक्ट्रॉन्स देयर, सो इसको आ गया पॉजिटिव क्यू. तो भाई अगर 1 मिलियन इलेक्ट्रॉन्स इधर से इधर मूव करे तो कहां जाएंगे? यू कैन नॉट क्रिएट चार्ज, यू कैन नॉट डिस्ट्रॉय चार्ज. लॉ ऑफ कंजर्वेशन ऑफ चार्ज. If this is losing some electrons, this is gaining exactly equal electrons. So this is supposed to get minus q. क्योंकि ओवरऑल सेंटर पीस देखो ना, आइसोलेटेड है, इट्स नॉट कनेक्टेड टू एनीथिंग, इट्स जस्ट इन वैक्यूम. वो जो बीच का पोर्शन है उसकी बात कर रहा हूं, दिस पोर्शन, दैट एच काइंड ऑफ थिंग, इट्स आइसोलेटेड, नॉट कनेक्टेड टू एनीथिंग. इट वाज न्यूट्रल, इट इज न्यूट्रल, इट विल बी न्यूट्रल. सो माइनस क्यू आ गया. Similarly, this becomes plus q because that minus q gives plus q here, minus q. Look at the symmetry here. And ultimately, agar a zillion electrons were coming here, a zillion electrons are leaving and coming back here. Conservation of charge. So in a nutshell, what is happening here? जितना भी capacitance किसी का भी है, we don't really care. All of them have equal charge. This goes along with that. 10th में पढ़ा था, 2 resistors in parallel. They have the same current. क्यों same current? Why? Did you think about it? एक इलेक्ट्रॉन इधर गया, वो इलेक्ट्रॉन इसमें भी जाएगा, 50 इलेक्ट्रॉन इसमें गए, 50 इसमें जाएंगे, मिलियन इलेक्ट्रॉन्स इसमें गए, मिलियन इसमें जाएंगे. तो नंबर ऑफ इलेक्ट्रॉन्स फ्लोइंग पर सेकेंड हियर इज एग्जैक्टली इक्वल टू नंबर ऑफ इलेक्ट्रॉन्स फ्लोइंग पर सेकेंड हियर. रेट ऑफ फ्लो ऑफ चार्ज पर यूनिट टाइम इज सेम. Current is rate of flow of charge. So current here, same. Same logic applies here. Doesn't matter. Resistor बड़ा था छोटा था, doesn't matter. In series they have the same current. Capacitor बड़ा है छोटा है, doesn't matter. They have the same charge. Done. इसका आंसर क्या आ गया? 1:1:1. I'll show you the sample response there, but this is it. You're done. Now, even though the question is not asking, this is beyond the question. Think about potential now. पोटेंशियल कैसे करोगे? C इज इक्वल टू क्यू बाय वी. ठीक है, अब Q तो कांस्टेंट है, तीनों में बराबर है, तो whoever has more capacitance will have the same less potential. It goes inverse proportionality now. So जिसका इसका अगर C3 is 3 microfarads, it's going to have the least potential here. This one will have the maximum potential. This is not asked in the question, but you might get this kind of question. ये strategy बना लिया, अब लिखना तो फिर तो piece of cake है यार. Let's see how to write the answer here. 1:1:1. है ना? You give the logic also. You write that because they are in series, each capacitor is going to get the same amount of charge. Okay, चलो भाई, next question. Obtain the relation between electric field and potential. Again, 3-mark question. 3-mark question cannot be written in one line. You have to give all the steps in there. But before you write any of the response, you're supposed to make the answer in your mind. जैसे कुछ भी काम करते हैं, building also if you have to make, you make a plan for that. You make a naksha for that, right? That's what you're doing. When you read the question, spend some seconds, few seconds framing this, because I'm explaining it looks like इतना टाइम लगा रहे हैं सर ये सब सोचने में. नहीं, तुम तो फटाफट सोचोगे ना यार. तो just think about it, make the response in your brain and then you start writing the answers. Obtain relation between field potential. अब सोचो field होता है something like force, potential होता है something like क्या work, है ना. तो सिंपल सा आ गया, सिंपल से तुमने इसको बना लिया. मैं एक बार यहाँ लिख के दिखाता हूँ. So think about, there is an electric field here, है ना, ये electric field है. Let's say it's a uniform electric field. For simplicity, this can be done with varying electric field also. Let's keep our life simple. यहाँ पे एक चार्ज है Q, ठीक है, इसको Q मान लिया. Q will experience a force, है ना, Q times E in this direction. Suppose I move it a little in this direction. क्या होगा? Work done. Work done is force multiplied by the displacement. अब force उधर है, displacement इधर है, तो work done कितना हो गया? Tiny little work done is what we are talking about. Because ultimately I'm going to pull it a longer distance, but I am saying let me pull a tiny little distance here. So delta work done is how much? Q times the electric field divided by whatever distance I was moving, right? Divided by, multiplied by, my bad. Tiny distance that was moved there, right? Work is force, so this thing is force here, है ना. उसको मैं नहीं लिखता क्योंकि many students will think कि मैं उसको डिवाइड कर रहा हूँ, इसको भूल जाओ, ठीक है. इसको समझो, QE is the force and multiplied by DL, that is the work done. पोटेंशियल की बात हो रही, पोटेंशियल इज ऑल अबाउट 1 कूलम ऑफ चार्ज. तो Q को इधर ले आओ, तो तुम्हारे पास क्या आ गया? dW by Q. अभी स्ट्रेटेजी बना रहे हैं मन में, और वर्क डन नेगेटिव है इसमें, क्योंकि फोर्स इज इन वन डायरेक्शन, displacement is in the opposite direction. So there was supposed to be negative sign, minus of E of dl. अभी dw by q क्या है? ये तो potential है, work done for 1 coulomb of charge. So there you go, dv equals to negative of E times dl. यही करना है. इसको एक बार फ्रेम कर लिया आंसर को, फिर अपनी सुंदर सी हैंडराइटिंग में you're going to be writing this. मैं एक बार दिखा देता हूँ. ये 3 मार्क का क्वेश्चन था. You're not supposed to write one line for that. You're supposed to make the picture there. You're supposed to write all this. And then you're supposed to show that E is negative of the derivative of V with respect to that X or L, whatever. हो गया? चले, next question. Okay, I'll move out here so that you can see the full response there. Yeah. Derive the expression for the capacitance of a parallel plate capacitor without any dielectric medium between the plates. Right? अब ये देख के लगता है कि यार ये तो फिर बड़ा सा derivation in the book, CBSE book and all that. That icon tells you it's one of the easy questions to deal with. इस icon का मतलब ही है ना, it looks like all this but it's a straightforward. क्या करना है? Simple case है. Let's actually not even use a picture. Let me show you. दो प्लेट है ना. कैपेसिटर इज यूजुअली अबाउट 2 plates. यू कैन हैव 1 plate but usually 2 plates. सो लेट्स टेक 2 plates. एक प्लेट ले ली, एक और प्लेट ले ली. एक को मैंने इलेक्ट्रिक फील्ड दे दिया, नॉट इलेक्ट्रिक फील्ड, चार्ज है ना, चार्ज दे दिया इसमें नेगेटिव सिग्मा. मीन्स चार्ज पर यूनिट एरिया. 1 square meter of the plate has this much of charge and this will have equal and opposite charge, है ना. चार्ज डेंसिटी दे दी. Now remember Gauss law use करके we derived that electric field around the plate is sigma divided by 2 epsilon naught, right? Now let's look at the point here. This point will have 2 fields, one because of positive, one because of negative. Positive के कारण that direction, negative के कारण this direction. Equal and opposite, my friends. So this one is sigma by 2 epsilon naught. This is going to be equal and opposite sigma by 2 epsilon naught. They cross out. There is no electric field here. By the same logic, there is no electric field here. तो प्लेट्स के बाहर there is no electric field. Look at inside the plate. इसके अंदर क्या हो रहा है? इसके अंदर story is different. Because of positive charge, there is an electric field here. And because of negative charge, also there is an electric field here. तो दोनों contribute कर रहे हैं in the same direction. They are going to add up. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught gives you sigma by epsilon naught. है ना, simple है. Half plus half is full. So this gives you electric field. So let's write down. Electric field is sigma by epsilon naught. पर अभी बात नहीं बनी because we have to derive the relation for capacitance. अब capacitance क्या होता है? Capacitance is Q डिवाइडेड बाय V। अब ना यहाँ तो Q है ना V है, लेकिन हमको पता है this is related to V and this is related to Q. So let's substitute that. If the distance between the plates is D, let's say, है ना, अभी किया था पिछले क्वेश्चन में. So what will be the work done in 1 coulomb of charge? E times of D, है ना. So V is E times of D. So E is what? V divided by D. So यहाँ पे लिख दो V divided by D is equal to सिग्मा क्या है? चार्ज डेंसिटी. चार्ज डेंसिटी मीन्स चार्ज पर यूनिट एरिया. अगर तो चार्ज प्लेट का Q है तो उसका एरिया A है, तो दिस इज सिग्मा. ये आ गया. अब कैपेसिटेंस चाहिए. कैपेसिटेंस इज Q बाय V क्रॉस मल्टीप्लीकेशन माय फ्रेंड्स. Q बाय V ये लिख ही देता हूं मैं. Q बाय V इज कमिंग आउट टू बी एप्सिलॉन नॉट A डिवाइडेड बाय D. बस हो गया, डेरिवेशन हो गया, खत्म हो गया, है ना. सो बट यू स्टिल हैव टू प्रेजेंट इट. सो हाउ डू यू प्रेजेंट दैट? सो लेट्स सी दैट. ये क्वेश्चन था, ये सॉल्यूशन हो गया. देख लो एक बार, ढंग से देख लो. है ना. ये यू हैव टू ड्रॉ दिस पिक्चर, यू हैव टू शो ऑल दैट कि इलेक्ट्रिक फील्ड आउटसाइड इज जीरो, है ना, दोनों तरफ. एंड बीच का जो है दोनों का ऐड हो जाएगा. दिस इज जीरो, बट दिस वन एड्स अप. This adds up to sigma by epsilon naught, and then the next slide is whatever we covered already. तो ये आंसर आ गया. If there was a dielectric, and this is not part of the question, a little extension there. If there was some dielectric there, then you do that. Instead of epsilon naught, there will be epsilon naught multiplied by epsilon r. उसका permittivity add कर देंगे. Okay, let's look at the next question here. That icon tells you it's a simple question, है ना. बुक में देखेंगे तो क्या दिखता है? इतना बड़ा डेरिवेशन हो क्या रहा है यहाँ पर यार. बट दैट आइकन टेल्स यू इट्स अ पीस ऑफ केक. तो लेट्स अंडरस्टैंड व्हाट दिस इज अबाउट. इलेक्ट्रिकल पोटेंशियल इज अ प्रॉपर्टी ऑफ ए पॉइंट हियर. व्हाट डज दैट मीन? लाइक a field is a property of the point. At this point, if I put 1 coulomb of charge, the force experienced by that. Similarly, potential is a property of this point. If I have to bring 1 coulomb of charge to this point, how much is the work done? कैसे? And why will the work be done, by the way? Let's see. Let's say there is a positive, so let's say there is a positive 1 coulomb of charge sitting at infinity. है ना, infinity पे रखा हुआ है. अब उसको मेरे को इस पॉइंट पे लाना है. How much work done? Zero work done. क्योंकि एक बार मैंने जाके उसको किक कर दिया फुटबॉल की तरह. It's going to come on its own. Newtonian physics. It says a body at rest continues to be at rest. But if a body is in motion, it continues to move. Continues to move. आ जाएगा यहाँ पे, फ्री में आ जाएगा, कोई काम नहीं करना. But unless there is a force applied. Now what is the problem? Problem is this charge here. पहले तो फ्री में आ जाता, अभी मैंने यहाँ चार्ज रख दिया. What is going to happen now is as the charge is coming this way, this is repelling that and it is going to stop somewhere. In order to make sure it comes here, I have to push now. मेरे को वहाँ बैठ के ना खड़े होके push करना पड़ेगा. So whatever work I do, this is not the technically correct way of understanding, 100% correct way of understanding potential, but this works with every student and this is going to be acceptable in exams also. So the work you do to bring 1 coulomb of positive charge from that point to this point is going to be the amount of potential of this point. That's a property of this point. Because of this charge, this is the reason that we have to work. So let's understand what's the big deal. We know force multiplied by displacement is the work done. Two problems. Number one problem, the distance itself is infinite. So how will you say work is force and displacement? Now this is infinite amount of distance. Second problem, force is not constant. Force is the Coulomb's force, K, Q1, Q2, but divided by the distance square. The force is changing, it's a variable force. अब जहाँ variable word आ जाता है वहाँ integration आता है. Let's do that. And this is a simple integration, let me tell you. So अगर if you're not comfortable with integration, stay extra attentive here. I'm going to simplify that. In integration, you look at the start position, you look at the end position, you take some point on the way. Like the charge was coming here, बीच में pause करके break मार के intermediate position पे या freeze कर दिया time को, break नहीं मारा, freeze the time and the charge is somewhere at intermediary position. मेरे को चाहिए था potential at a distance of r, लेकिन मैंने क्या किया, I pause somewhere at a distance of x on the way, रुक गया वहाँ पे, time रुक गया. And then what I say is, if at that position I try to move this by a tiny amount of dx, है ना, थोड़ा सा displacement कर रहे हैं, the displacement is so small कि I know the force is variable, but because the displacement is so small, I can say throughout the journey of dx, the force is same. And how much is the force? kq times that charge divided by the distance square. So that force is constant throughout the journey for dx here, है ना, dx amount पे चले हम लोग, तो कितना वर्क करेगा? इतना वर्क करा. So tiny amount of work, infinitesimally small amount of work, because I need the whole of the work. I'm talking about the small portion of the work there. That is equal to the force. Force कितना है? K times Q1, है ना, Q1 डाल दिया, Q2 तो 1 कूलम है, तो you don't even have to put that, divided by the distance square. The distance is x. ये तो force हो गया. Force multiplied by the displacement. I am displacing it by dx. तो ये मेरा work done आ गया for the tiny amount of journey here. But I'm not interested in that. I'm not done. I'm interested in the whole of the journey. So this journey plus this journey plus this journey. तो उसका मतलब क्या? इंटीग्रेशन करना है, and you're done. Integrate. इंटीग्रेशन के लिमिट्स क्या है? द इनिशियल पोजीशन इज इंफिनिटी, द फाइनल पोजीशन इज एट अ डिस्टेंस ऑफ r. इंटीग्रेशन इज ऑफ 1/x² इज -1/x. डन, हो गया, है ना. इतना सिंपल है, इतना सिंपल. आई विल शो यू हाउ टू प्रेजेंट इट इन द एग्जाम. ये देख लो इसको, because see, it's a 5-mark question. You're supposed to write all the steps in there. You have to do that. But before you write those answers, you frame the answer in your mind. You think, और ये करना है, अच्छा इसके बाद ये करना है, और बाकी तो फिर presentation skills, you have awesome skills there. So then I'll see you tomorrow, and before you log out, make sure that you subscribe the channel. If you have not done so, press the bell icon so that you can get notifications about the awesome courses coming up. And also make sure that you share the knowledge with your friends, relatives, make them aware about the YouTube channel here. We are always going to be free here, free education. Plus, one more thing, if you have not downloaded the app, please download it now. You're going to get all this PDF in there. So make sure that you do that, and let's say good night to everybody. Happy night. I'll see you same time tomorrow. Bye bye.